Okay, hopefully you guys have started to read pages 295 through 302. If you haven't, I would encourage you guys to do that, as well as reading pages 323 through 325. I do want to talk about a couple things with you guys. The first thing I want to talk to you guys about is finding the probability of some special events. So one of the types of events that you guys learned about was the idea of mutually exclusive, or something called disjointed events. That's events that cannot happen at the same time. If I think about Venn diagrams, it's where I have two circles and they have nothing in common. That middle area is not covered. Okay? So in this case, if we're trying to find the probability of mutually exclusive events, that means that there is no intersection between A and B. That's what that's talking about. Okay? So all I have to do for those events is just add the probability of A and the probability of B together. So for example, students at a local high school are made to participate in only one sport each season. That's hence why it's mutually exclusive, because they can't do two things at once. During the fall, 28% of the students play basketball and 24% are on the swim team. What is the probability that a randomly selected student athlete plays basketball or is on the swim team? So what we're doing is we're taking event A, which is basketball, and B, which is swim team, and we're adding those two probabilities together. So probability of A or B is going to equal the probability of A plus the probability of B. So in this case, I'm just taking 28% and adding 24%. So I get the probability of both these events, A or B, happening is 52%. Let's look at this one. It says the student athlete may participate in only one sport. 50% play baseball and 23 are on the track team. What is the probability that both of them, that they could be playing basketball, baseball, or track? So in this case, we're just we're taking 15% and adding 23% to get 38%. Okay. So we have a bag of chips. We have 3 blue, we have 6 black, we have 2 green, and 4 red. So overall, I have 3 plus 6 plus 2 plus 4. So it looks like we have 15 chips overall. So in order for us to find the probability of green chips or red chips, well, what's the probability that it's green plus the probability that it's red is going to help us find that, because there is no intersection. You can't have a chip that's both green or red. So green chips, looks like I have 2 out of the 15 are green, and red is 4 out of 15. So if I add those two values together, looks like I have 6 out of 15. So this next one, we're taking the probability of blue, we're taking the probability of black, and adding the probability of red. Well, red we already knew was 4 out of 15. What is the probability that it's black? It's 6 out of 15. And then what is the probability that it's blue? It's 3 out of 15. So when I do all that, it looks like it's 13 out of 15 is the probability of that. Okay? Alright, so this next one. You should try these, and we'll talk about those tomorrow. These are in your book. Alright, so overlapping events. These are not mutually exclusive. They are not disjoint. There is intersection between the two events happening at the same time. Okay, so this is the notation that you guys have in your notes. This is the notation that you guys will see in your book too. Alright, so what is the probability of rolling either an even number or a multiple of 3 when rolling a standard number cube? So when I look at this, there's 2 events that are happening. I have an even number, and I have a multiple of 3. So when I look at this, I know for even, when I roll a standard cube, those possible events would be 2, 4, and 6. When I roll a multiple of 3, well, I know that's 3 and 6. So in this case, I'm trying to find the probability that it's even, the probability of multiples of 3 and the probability that it's even and a multiple of 3. Well, if I look at event A, which is even numbers, looks like I have 3 possibilities. Okay, so it looks like 3 out of 6 chance of being an even number. A multiple of 3 looks like I have 2 possibilities of that. So that's 2 out of 6. Okay, now let's talk about A and B happening at the same time. How many times does A and B happen at the same time? When is my overlap? It looks like it only happens once. It's 6. Okay, that happens once. So that's 1 out of 6. Okay, so I'm going to be taking the probability of event A, or evens, is 3 out of 6. I'm going to take the probability of B, which is 2 out of 6, and I'm going to subtract the intersection of them, which is 1. When I do that, it looks like I would get my answer to be 4 out of 6. Right. I'm going to look at number 5. What you guys do. So what is the probability of rolling either an odd number or a number less than 4 when rolling the dice? So when I look at this, event A would be odd, event B would be number less than 4, and then A and B is both odd and a number less than 4. So if I look at an odd number, rolling the standard number cube, 1, 3, and 5 are my possibilities. 1, 2, and 3 are my possibilities for event B. And then for the other one, it's 1 and 3. Both are odd and a number less than 3. Nothing else. So when I look here, this is 3 out of 6 is the probability of me rolling an odd number. It's 3 out of 6 is the probability of me rolling a number less than 4. And it's 2 out of 6 is the probability of me rolling both an odd and a number less than 4. So I'm taking 3, 6 plus 3, 6 minus 2, 6. And when I do that, I get my probability of A or B to be 4/6 or 2/3. Okay. Hopefully this was helpful for you guys. We will talk more about this tomorrow.